In the previous lecture, we had already seen the metrics of transformation in terms of the Cayley Klein parameter. This we have already proved. So, in this lecture, we will do the next theorem, which is really interesting. So, in this theorem, what we are doing is we are establishing a relation between the Eulerian angles phi, theta, and psi that we had seen a lecture like two lectures before. We know that Eulerian angles are the angles which are the rotation angles which helps us to coincide the space coordinate with the body axis coordinate. Then we saw the Cayley Klein parameters. Even the Cayley Klein parameters are responsible for the or can be used in order to study the orientation of a rigid body. Now, in this theorem, what we are going to do is we will establish the relationship between the Eulerian angles phi, theta, and psi, and the Cayley Klein parameters alpha, beta, gamma, and delta. Okay, this is really interesting. For this theorem to study, you should already know what are the previous theorems, otherwise, you will not understand anything in this lecture. So it would be better that before studying this theorem, you should study the previous two theorems, because I am going to use this equation number 8 everywhere in this theorem. So you should know what x plus is. X plus is nothing but x plus iy, and you should know what x minus is. X minus is x minus iy. You know this x lower suffix plus and this x lower suffix minus, what they denote you should know. Okay, so now I will proceed with the theorem. This theorem, yeah. So basically we know that, since I've already told you that Eulerian angles are the three successive angles of rotation such that which help us the helps the space coordinates to coincide with the body set of x's. Okay, and we also know that the Cayley Klein parameters alpha, beta, gamma, and delta are also used to describe the orientation of a rigid body. So, in this theorem, we will try to find out the relationship between them. Since we already know that in the first rotation, what we do is we rotate the axis about we rotate the space coordinates about the z axis. Okay, when we rotate it about the z axis, let us consider that q phi be this type of matrix in the form of Cayley Klein parameters, that is alpha, beta, gamma, and delta. And we have already found out the value of q phi in terms of the angles, right? What we are doing is we are rotating the entire axis we are rotating the entire coordinates about the z axis. If we are rotating it about the z axis, obviously that the z coordinates will not transform, only the x and y coordinates will transform, and the transformation would be given as like this. What we are doing is we are rotating the z axis through an angle phi. If I am rotating it with an angle phi and I am rotating it about the z axis, obviously the z coordinates will not change. The x and y coordinates will change. And how will they change? They will change like this. This we have already studied why all this happens. Okay. So now we will write these equations as, see, x plus dash means the transformed coordinates. So obviously x plus dash will be x dash plus iy dash. Okay, now we already have the value of x dash over here. So if I will use this and this values in this equation, you will see that you will get these terms. You should know that e minus I phi is nothing but cos phi minus I sin phi. Similarly, if you place these terms, the imaginary things will get cancelled and you will get the equation like this. So if I take e to the power I phi common, I'll get x plus iy, and this is nothing but x plus. We denote x plus by x plus iy. In the same manner, you can find the value of x minus dash, which is x dash minus iy dash, and you will get such equations. And obviously, since we are rotating through along z-axis, z coordinate will not change. Okay, now we have found out few values. I have already written these values here. So what I will do is, since I've told you that we are going to use equation number 8 of the previous example. So this was my equation number 8. You can see the value of x plus dash over here, and now in this theorem also we have the value of x plus dash over here. So what I will do, I will come, I have written the equation number 8 here also. So see, if you compare x plus dash here and here, you will see that we have the coefficient of x plus as e to the power I phi, and here I have the coefficient of x plus as delta square. Thus the value of delta square becomes e to the power I phi. In the similar pattern, when I will compare x minus dash with x minus dash over here, we will get the value of e. See here, the coefficient of x minus is e to the power I phi, and here the coefficient of x minus is alpha square. So I will get alpha square equals to e to the power I phi. Okay, now what I will do is, I will use this equation z dash is equals to z, and here z dash is equals to z. So if you will observe this and this equation, you will see that it has only z term. So obviously, in order to get z term, this has to be 0, that is beta into delta, and alpha into gamma has to be 0, and this value has to be 1. So since we know that alpha into delta plus beta into gamma equals to 1, so obviously alpha into delta has to be equal to 1 and beta gamma will be 0. Okay, because alpha into delta is actually equal to 1. If you will see from here, you can find the value of alpha, that is under root of e I phi, that is e to the power I phi by 2, and the value of delta would be e to the power minus I phi by 2. If you multiply both these, you will get e to the power I phi by 2 minus I phi by 2. Hence, you will get e to the power 0, and the value of e to the power 0 is 1. Therefore, the value of alpha into delta is 1. So, if this value of 1 is 1, that obviously beta into gamma has to be 0. Therefore, beta equals to 0 and gamma equals to 0. Hence, I have found all the four values, that is alpha, beta, and gamma. So I will put these values in this equation. I will get alpha, as I've told you, the value of alpha, if I take its root, it would be e to the power I phi by 2, and the value of delta, as I will take its root, it would be e to the power minus I phi by 2, and beta is 0 and gamma is also 0. So this is the corresponding matrix Q phi, that is when I will rotate my coordinate axis along z axis with an angle phi, I will through an angle phi I will get this as my matrix. Okay, so from here we can say that we have obtained the relationship between phi and alpha, beta, gamma, delta. Similarly, I will do this for rotation number 2. Since I know in the second rotation, in the 3D space, what we do is we rotate with an for about an with an angle theta, and the rotation is done about the new x-axis. Like after the first rotation, the coordinate axis will change its position, and the new x-axis we will get, and we will do what we'll do is we'll rotate the entire coordinate axis about the new x-axis with an through an angle theta, and hence we will obtain these as my new coordinates. Like these are the coordinates after such kind of transformation. Since I am rotating through z axis, z coordinates will not change. Okay, similarly, all the things that I have done previously in the first rotation, I will repeat here, since I know that x plus dash is given by x dash plus I y dash, and so I will replace this. See, I know that x dash is given by x and y dash is given by y cos theta plus z sine theta. Now we know that cos square theta by 2 plus sine square theta by 2 is 1. So x into 1 would be equal to this. Now I y cos theta plus I z sine theta as it is. When you will solve it, you will clearly understand that this would be equal to this. Similarly, I will obtain the value of x minus dash and z dash. Okay, when you will obtain all these values, see, you can write it in this form also, where x plus is x plus iy. What you do, you have studied in 12th standard the half angle formula. I know that cos 2 theta is given by cos square theta minus sine square theta. So cos theta would be equal to cos square theta by 2 minus sine square theta by 2. You replace it here, and sine theta would be equal to 2 sine theta by 2 into cos theta by 2. When you will use the half angle formula here and you will solve it, you will get that the coefficient of x plus iy is cos square theta and the coefficient of x minus iy is sine square theta, and the remaining term, this term, is as it is. See, sine theta can be written as 2 sine theta by 2 into cos theta by 2. Now we know that x plus iy is nothing but, in short, we use it as x plus, and x minus is nothing but x minus iy. Similarly, you can do it here also. Sorry, I have been saying phi in place of theta by mistake. We know that I am considering angle theta here. In the last problem, I considered angle phi. So this I am using it by mistake. Obviously, everywhere we are using theta. Okay. So now where we have reached here to z dash. Right, again what I will do is I will compare these values x plus dash x minus dash with the equation number 8 of the previous problem that I have written here also. Okay, so after comparing, you will observe that the value of alpha square is equals to delta square, and this value is equal to cos square theta by 2, and these values equals to, this is very simple. When you compare your x dash y dash z dash that you have obtained here to these equations, you will clearly understand that we have the value of alpha square, delta square, beta square, and gamma square. I will take the corresponding roots and I will get the value of alpha, beta, gamma, theta, and those are nothing but my Cayley Klein parameters. So here I have got the matrix q theta in this form, where this is alpha, beta, where this is alpha, this is beta, this is gamma, and this is delta. Hence I have got the value of alpha, beta, gamma in the form of theta. Okay, similarly you can do the entire thing in the third rotation. We already know that in the third rotation what we do is, the new z axis we have, which we have obtained, now we will rotate the entire coordinate axis along the new z axis with by an angle psi. So this time I will rotate by an angle psi and the rotation would be along the z axis. Since the rotation is about the z-axis, obviously the z-coordinate will not transform. We will get the transformed x-coordinate and y-coordinate, and we name the transformed x-coordinate as x dash and the transformed y-coordinate as y dash, and z dash will be equal to z. Okay, and the similar pattern that I have done in the previous two rotations, I'll get the value of x plus dash and the value of x minus dash and z dash. Again, you will compare to the same equation number 8 of the previous example that I have written over here. See this one. Again, I will compare the values of x plus dash, x minus dash, and z dash with these equations, and I will get the value of alpha, beta, gamma, and delta. So see, I've got the value of alpha square as e to the power I phi. This is delta square and this is beta square, and gamma square. These are 0. So beta and gamma is 0, and I have got the value of q psi, that is a matrix. Okay, so finally you have the values of alpha, beta, gamma, delta in terms of psi, but we have to find like we have to take the product of all the three matrices, so that the combined effect of the rotation, like the first rotation, second rotation, and third rotation, we have to see the combined effect, that is the combined rotation. So in order to obtain that, obviously what we'll do is we will multiply all the three matrices. This we have already done in a lecture, like one lecture before what I have taught you. So Q is obtained by Q psi into Q theta into Q phi. After multiplying, this is a simple matrix multiplication 2 cross 2 that you have already studied in your 12th standard. First, these two matrices are multiplied. Sorry, first these last two matrices are multiplied, and then this matrix is multiplied, and you will get here alpha, beta, gamma, delta. Now, similarly, comparing in the same way, you will see that the value of alpha is equal to this, the value of beta is equals to this, and the value of gamma is this, and the value of delta is this. Hence, I have got the values of alpha, beta, gamma, and delta in the form of angles pi, theta, and psi. We know that the angles pi, theta, phi, and psi are nothing but my Eulerian angles or the rotation angles, and we know that these angles are used to obtain the rotation of the axis, space axis with the body axis. That is, we get aligned, both the axes we can get aligned. Okay, so this was our question. We had to find the relation between alpha, beta, gamma, delta with phi, psi, and theta. Okay, I hope this question is clear. Now the next question I will skip. I will take this in the next lecture. I will take the next theorem, which is really easy for you to understand. See, what is it written? Find a real matrix of orthogonal transformation in the 3D dimensional space corresponding to the unitary matrix. What you have to do is basically you have to find a real matrix of orthogonal transformation, okay, corresponding to the unitary matrix this. So we know that this is the given condition they are asking us to take. We have to use this condition. Here we know the value of p dash. This I have done in already the previous example. This question is really easy. You can do it by yourself also. It's just the calculations. Calculations are also really easy. The way it is looking is not like that. It is really easy. You can calculate by your own. So see, take a matrix P in a particular form which is trace free, that is we are using a self adjoint, okay, a self adjoint matrix, and we know that the unitary matrix Q is here, and we have to use this as the unitary matrix. So we know the value of P dash. Okay, this we have seen in the previous example, the value of P dash. So equation number one, if you will use this value of P dash over here, you'll get this equation, and we know the value of P also. So when you will multiply all this, okay, you will come up to this equation. After that, we have to do nothing. We have to just compare, and you will come up to this equation. So these equations are really simple. So after solving up to here, you will reach here. Okay. Now this is nothing but x dash plus iy dash, x dash minus iy dash, and z dash. When you reach here, you have to find the value of x dash, y dash, and z dash. After solving this for x dash, y dash, and z dash, you'll get the value of x dash as x, y dash as this, and z dash as this. You will write it in the matrix form. Hence, you have got the matrix A, this matrix, which is helping for such kind of transformation, which is responsible for such kind of transformation. So finally, you have the matrix A, which you had to find in this question. This question is really elementary and easy, so you go and try by yourself. Okay, I will try to complete this chapter as soon as possible. Then I will shift to the fifth chapter. So for this lecture, these two questions I have solved. I would want you to practice it by yourself. Only then you would be able to find the solutions. Okay.